like Mercury's DNA, our structure as a company and how we're built, is we like to solve very, very complex issues. And our ability to utilize compute engines to take a very complex problem and shrink it and break it up is one of the things that's really made our company successful. If you look at how that streams into the organization structurally, is we have hundreds of people that think this way. So the power of our team to be able to look at very complex problems, break them down, provide innovative ways to solve these complex problems is one of the things that I think makes our company very, very successful. Our ability as a company, and if you look and see how we look at things from a fabric perspective, we have the ability to look at things, and that's what's made our company's DNA evolve, is our ability to take that fabric and connect very, very complex boards together as subsystems. When you start looking at that subsystem fabric, the really, really neat part that's happening right now is speeds are evolving geometrically. It's very much like the early computer days where the computers were changing in speed, speed, speed. The same thing is happening with all of the silicon right now. So we have situations where you go back to our legacy race or race plus days as a company where we have thousands and thousands of systems out there that basically utilize our serial rapid I/O type fabrics. With the next generation fabric speeds in PCIe 2.0 at 5 gigabaud, or you look at serial rapid I/O at 6.25 gigabaud, or the next generation now we're working on PCIe 3.0 at 8 gigabaud, or you look at things like our 10KR stuff we're doing where we're moving 10 gig data rates inside of our labs right now. The evolution of the speed change is really, really going to give us an amazing ability to compute very, very complex problems in size, weight, and power that we could not do just 3-4 years ago. So the evolution of speed right now is really making Mercury a fun place to work. The whole open standards approach is a very, very big issue for not only us as a company, but our customers as either subs to primes or primes, but ultimately either the government or the end users who want to use our products. As they look at an open standards capability, we need to be able to make items, and whether they're a switch fabric module, we call SFMs, or whether they're a high compute density board, we call HCDs, or a low compute density or a low density server, we need those to be able to plug into systems and interoperate. It's one of the huge reasons we drove Vita 65. Ultimately was brought into Vita as an open standards, so we could have backplane topologies that allowed these cards to go in, be plugged together, and actually operate. We used to work in this environment, we literally called it plug and pray. You put the modules in, you hope they didn't smoke first, okay, check. Second piece was, did it work? A lot of them just didn't. So by driving some of these open standards inside of Vita, and Mercury is a very, very large and spends a tremendous amount of time, energy, and money in that space to be able to make sure that we're in, not just us, but some of our either competitors or our suppliers are building ecosystems that we can use different types of cards, put them all together, and actually make them work. So it really reduces the risk for us to have the ability to take and get a product to market in a much quicker period of time, instead of spending 6 months or a year debugging in labs. So the open standards approach, in my opinion, is probably one of the largest things that's going to make our whole industry grow. I think sometimes I consider myself just a big kid. In my job, you call them building blocks, I call them Legos. We take and we build and we modularize a very complex problem down to the simplistic piece of a design we possibly can. So by us taking and looking at a subsystem as a big block set of Legos that we can take and have different things all vetted, all analyzed, all done, quote, quote, complete capable, it allows us to be able to take a card, multiple cards. Another example might be a Vita 62 power supply that we can plug in, and all of these designs actually plug together and they just work. So not having to re-engineer a power supply for every single system makes a huge difference in our cycle time as a company to be able to bring some of these subsystems to market. We've literally cut the time by greater than 50%. What used to take us 2 years to do, we now do in less than a year. Some of our customers want it even faster. The more Legos or the more module blocks that we build at a subsystem level, a backplane level, a module like our new air flow-by technology level, some of these different building blocks allow us to put systems together now at speeds that we could never do just 2 years ago. So I see huge advantage in our approach. There's a lot of different companies out there that have the ability of building modules. There's only a few of us right now that have the ability to really go pick all of these modules and put them together successfully so they all plug and not pray, they just work.